Hey everybody, welcome back to our Algebra 2 series. Today we're finishing up our 3.2, 3.3 or function information, and this time we're talking about symmetry. So we talked a little bit about the algebraic test for symmetry, and we'll just practice that here. Let's just go ahead and work this through. We talked about going with the negative x. If you plug in negative x for x, we want to just see what that does to our function. And in this case, excuse me, that's a 3 down there. So in this case, if you did that, it appears that you would never be able to get that negative away from the x in order to create either of two situations. So there are two uh, outcomes that we're kind of spying on. We're looking for, does f of negative x equal f of x? And that's the first one. And does f of negative x equal the opposite of f of x? And you notice in this case, we'll never be able to get the negative x plus 3 to either be that quantity or its opposite. So this would be neither for, it's neither even nor odd. So neither for this one, because we can't get that to be either f of x or its opposite. In the second problem, though, when we plug in a negative x for x, we get negative x quantity squared minus 4 times the absolute value of x. In this case, it's going to be a negative x plus 4. And we do see here that when we square numbers, we end up with x squared, and this is minus 4. And the absolute value of negative x is the same as the absolute value of x plus 4. And this gives us the same thing that we started with exactly. So that becomes f of x. So we just write f of x there. And we see that since f of negative x is equal to f of x, we say this is even, and there is symmetry over the y-axis. Oops, there we go. Okay, so that's the type of symmetry we're looking for there. Our final slide today is given a function, and then let's take a look at some of these things here. A couple of items to note. The graph does continue going up and to the right, and over here it keeps going to the left at a constant value. These are approximates, but let's just go ahead and put a couple of these things in here. It looks like 7 and 1 for our x-intercepts. Looks like 4 is the y-intercept. So let's look first at our domain of f. So part A, the domain is going to be x such that x is a member of the reals because it's going from left to right. Part B, the range of f. Now this one's a little bit trickier because we see that it's going up forever, but it kind of stops down here at this y value of negative 4. So we'll write down here y such that y is greater than or equal to negative 4. A little bit trickier than part A. Part C, x-intercepts. X-intercepts. I can say at, and then I can put 1 and 7, or I can write those as ordered pairs. So I would write 1, 0, and 7, 0. That's another way to write it. Either way is appropriate for x-intercepts. Let's go to part D. Part D, the y-intercept. Uh, and again, you can just say the y-intercept is 4, or you can put 0, comma 4. It's up to you how you want to write that. Either one of those is appropriate. Let's go to the next one, letter E. Intervals where the function f is increasing. So letter E, we want to write this in terms of x. So we do see that the graph is increasing here on this side, all the way from there, and it's decreasing over here on this side. So we know that we always go from left to right, and in the portion that's over here and to the far left there, that is definitely not doing anything. So it's just kind of staying at that same level. So first of all, it is increasing from the x value, and the x value here is 4. And so we would not write negative 4. We would say increasing on the interval from 4 to positive infinity. And the positive infinity is meaning going this direction, not going up. F is saying, I wrote that the wrong way. Like I'm going to write an f of x. What was I doing there? F. And then in this case, it is decreasing on the interval from, in this case, it's decreasing on the interval from 0 to positive 4. And again, this is the interval of x, so it's from here to here. Don't think of it as the positive 4 or the y value. Instead, we're looking at the x value. And the next one asks us for the intervals where the function is constant, or g would be this. Constant, and we can just say const on the interval from negative infinity all the way to 0. Again, we're going on the x-axis. Let's see if we've got a couple more things to put in here. Looks like we've got a whole list of items here. So it asks us for letter H, the number at which f has a relative minimum. So in H, they're saying the number. So when x is 4, it has a relative, or what we call oftentimes a local minimum. So that's this point right over here. That's a minimum because there are values to the right and to the left that are higher than that. So we would say when x is 4. The next question is, what is the relative minimum? So the minimum is negative 4 because that's the y value that corresponds to that minimum spot. Part J, I'm going to see if I can squeeze these last couple in over here. Letter J, what is f of negative 3? So in order to see that, I'm going to need to find negative 3. Here it is. I'm going to go up to there, find f of negative 3. Looks like it's on that constant area over there. So f of negative 3 is equal to 4. K, the value where for x, where f of x is negative 2. So it looks like we're going to have a couple of them. So you notice at negative 2, it looks like it's about here and about here. So we're going to estimate since we don't have an exact value, but it looks like it's at 2 and 6. Of course, that's saying where the function values for x, so the function is negative 2. So in k, when x equals, and those two numbers there look like 2 and 6, when x is 2 or 6. And finally, part L, we see there's no symmetry, so we're just going to write no symmetry. We know that one well. Okay, so this kind of wraps up some of those properties that we've been looking at for functions in Chapter 3. Hope that helps with work on your homework.